Okay, so now I'm doing question 5 over here. X and Y are two geometrically similar, or just similar, solid shapes. The total surface area of shape X is 450, and the total surface area of shape Y is 800. So I'm going to imagine that shape X is some kind of box and shape Y is some kind of bigger box. It's mathematically similar. I know the surface area of shape X is 450 and the surface area of shape Y is 800, so I get to calculate an area scale factor by dividing these two measurements. So I'm going to go 800 divided by 450. On my calculator, that's going to produce 16 over 9. Now I can write this as some kind of horrible recurring decimal, but I'm just going to keep it as a fraction 16 over 9. This is what I would multiply by to turn areas on X into areas on Y. Because it's a number greater than 1, it's going to make the measurements bigger when I multiply by it. Now I want to use this area scale factor to work out a volume later on. So in order to get to volume, I first of all have to go to a length scale factor. Squaring length scale factors gets me area scale factors. So I need to square root my length scale factor. I need to square root my area scale factor to get a length scale factor. This comes out as 4/3. Now to get my volume scale factor, I have to cube my length scale factor. That's getting me 64 over 9. I would multiply volumes on X by 64 over 9 to get volumes on Y. So the volume of X is 1,350 cubic centimeters, and to get the volume on Y I'd have to multiply by 64 over 9. I'm expecting an answer that's bigger, and if I don't get an answer that's bigger, I know I should have divided. So 1350 times 64 over 9 is getting me 9,600. That answer seems sensible, so I'm happy with what I've done. So this is yet another question which plays with the relationship between length, volume, and area scale factors. And just to clarify again, whatever my length scale factor is, my area scale factor is my length scale factor squared. My volume scale factor is my length scale factor cubed. In other words, length scale factor is the key to the other two. In this question I was given an area scale factor and I wanted a volume scale factor. So by square rooting to get back down to the length scale factor, I was able to then cube that to get to the volume scale factor. So that's what we're always trying to get to. Length scale factor is always the key to doing these questions. Cylinder A is mathematically similar to cylinder B. The height of cylinder A is 10 centimeters and its surface area is 440 square centimeters. The surface area of cylinder B is 3,960 centimeters squared, and I want the height of cylinder B. So the measurements I get to compare are surface area measurements. Surface area of A is 440, surface area of B is 3,960. So if I divide those two, I'm going to get an area scale factor. The area scale factor is 3,960 divided by 440, and we can work that out in the calculator. That's giving me an area scale factor of 9. Just as we discussed before, these are the relationships between length, area, and volume scale factors. So, if I square root the 9, I'm going to get the length scale factor. Now this question simply wants me to find a length on cylinder B, but even if I was after a volume calculation, I would still go to length scale factor first, so that I could get from there to a volume scale factor. Knowing the height of cylinder A is 10, and wanting the height of cylinder B, I just have to do 10 times 3, the length scale factor, getting 30 for the height of cylinder B. Triangle ABC is similar to triangle DEF, and I want to find the lengths of the sides x and y. So before I can do that, I want to find some comparison. I notice that I know both of these sides and they're clearly corresponding to each other. And so I can see without any real effort here that the length scale factor is 2. I would multiply by 2 to go from the small shape to the big shape, and divide by 2 to go from the big shape to the small shape. So to work out y, I've got to take the 2 on the smaller triangle and times it by 2. Y equals 2 times 2, that's 4 centimeters. To work out the x over here, that's corresponding to the 12 centimeters on the larger triangle, so I have to take that 12 and divide it by 2 to get 6 centimeters for x. Now in this question we are not told that there's any similarity, but just like the very first question in the first video, we have to be able to spot similar triangles, and it's always going to be something to do with seeing these parallel lines. So I've got the 9 centimeters and the y centimeters, those are parallel lines. That's telling me that this small triangle over here is similar to the large triangle out here. Now because some of these lengths overlap, it's a really good idea to draw these two triangles separately before you start to try to answer the question. So here's my smaller triangle, and it's got a 5, a 9, and an x. The larger triangle has 5 plus 20, which is 25, x plus 28 on this side, and y down here. It's easy to miss these details if you don't draw the triangles separately. Now I'm looking for corresponding lengths. Well, the 5 and the 25 clearly correspond, and I can see a length scale factor of 5 between these triangles. So I can start off by working out the value of y. I have to multiply the 9 by 5 to get to the y. So y equals 9 times 5, 45 centimeters. Now getting x is a little bit trickier, but here's what we know. We know that this measurement times by 5 equals this measurement. X times 5, or 5x, has to equal x plus 28. And that's given me a simple equation to solve. 4x equals 28, so x must equal 7 centimeters. Two circles, x and y, are mathematically similar. I'm being given a comparison between their areas, so I can work out an area scale factor straight away. The area scale factor is 192 divided by 12, and 192 divided by 12 comes out as 16. The radius of x, in other words a length on x, is 10 centimeters, and I want to find the corresponding radius of y. So, I want to work out the length scale factor so I can compare the lengths. If I square root the area scale factor, I'll get the length scale factor, so that's 4. We can see from the areas they've given us that x is the smaller circle and y is the bigger circle. So I need to take my 10 centimeters from x and multiply it by 4 to get 40 centimeters for the radius of y. Now, we didn't necessarily have to use area scale factors and length scale factor to do this question. If I want the radius of circle y and I know its area, well, I could just use the area of a circle formula. But obviously the most straightforward way to do this question would be to use scale factors. And if they say similar to each other, then you won't really want to use the maths of similarity. That's what they're hoping you will do, and that's what the mark scheme will reflect. Two spheres, A and B, are mathematically similar. The radius of B is triple the corresponding radius of A. And hey, this is just really another way of giving us a length scale factor. The length scale factor is 3. The volume of A is 20, and I want to find the volume of B. So, well, to get a volume scale factor, we're going to have to cube our length scale factor. That's 27. So the volume of A is 20. I have to do 20 times 27 to get the volume of B. And 20 times 27 is 540 cubic centimeters. That's a pretty straightforward question transferring from length scale factor to volume scale factor. So our next question is about two cones. Cone A and cone B are mathematically similar. We're given a surface area for A of 120 and a surface area for B of 1080. So if I can compare the areas, I can work out an area scale factor, which is going to be 1080 divided by 1020, which is 9. I'm told the diameter of cone A is 8 and I want the diameter of cone B. So I'm going to need a length scale factor, which I get by square rooting the area scale factor and getting 3. Now, if I take the length on A and times it by 3, I get the length on the larger shape. 8 times 3 is 24, and that's the diameter of B. If it wanted me to compare the volumes, I could cube the length scale factor, get a volume scale factor, and use that. And that's the end of the similarity questions.